Hi guys, Mr. Biggers here, and today we are going to finish up Module 3, Lesson 8 on our third day of this unit. We're going to be talking about slopes and equations of lines. Make sure your name's on this paper, and if you're confused at any point, please make sure you rewind the video so you can rewatch and revisit key concepts. Okay, so just to review, slope-intercept form here comes in the form of y equals mx plus b, where m is known to be our slope, and b is known to be our y-intercept. So please make sure you have those written in. Okay, and there's also a diagram over here for you to see as well. Horizontal and vertical lines, this is kind of review from yesterday. So horizontal lines are y equals anything. So if an example would be y equals 2. That is going to be a horizontal line with 0 slope. Okay, that's an example. A vertical line is going to be an up and down line. So y or x equals 2 would be an example of this. This would be an up and down line, straight up and down, with an undefined slope. Undefined slope. Okay, we can see two examples of the lines over here. If we wanted to write equations, we know this one is a vertical line. Vertical lines have an x coordinate. So x equals wherever it intercepts the x. So we count from 0, 1, 2. X would be -2. Okay. This one has a y-intercept of -3. So y is going to equal -3. Those are the equations for those two lines, believe it or not. Since there's no defined slope, if we write it in y equals mx plus b, okay, it can't be written like that because there's no slope. There's no m here. So that's why that equation looks like this. This equation doesn't even have a y, so that's why it's not even in y equals mx plus b. The big thing to know about these is these two lines are perpendicular. So right here, they form a 90-degree angle just by definition. Horizontal and vertical are opposites. So since they're opposite reciprocals, they are going to be perpendicular lines, okay, which form a 90-degree angle. Okay, so opposite reciprocal for perpendicular lines. Remember this, okay? So here's some examples. We're going to do example 1. Please write this down. If I have a slope of 5/3, so these are going to be some slopes. So if I have a slope of 5/3, 5/3, the opposite reciprocal is going to be 3/5, and then we need to make it opposite, which means it would have to be negative. Okay. Another example would be if I had a slope of 5. So this is example 2. Remember, these are slopes. So if I had a slope of 5, that means I'm going up 5/1, up 5/1. Okay, rise over run, right? So if we're taking the opposite reciprocal of this, the 1 is going to flip to the top. The 5 is going to go to the bottom, and it needs to be opposite, so it would become negative since this one is positive. Okay, one more example of opposite reciprocal. Remember, we're dealing with slopes. Two different slopes here. So all of these lines, if they had these slopes, would be perpendicular lines, meaning they form a 90-degree angle. So if I have a slope of -3/2, the opposite reciprocal would put the 2 on the top, and it would put the 3 on the bottom, and then I know I have to be the opposite of a negative. The opposite of a negative is a positive, so our opposite reciprocal for that is 2/3. So those are examples of opposite reciprocal slopes, okay? They make a product of -1. So if you multiplied these two fractions together, you would get -1 as your answer. Okay, the notes didn't copyright, so please go ahead and fill in all of these blank boxes as parentheses. Or actually, never mind. Please fill these in as follows. So please fill these in as follows. Okay, so that's how they should look. So make sure those are filled in as followed, okay? So example 5 here, we're going to get into this pretty quickly. Parallel to this line. So if we look at our line, it is in y equals mx plus b. Okay, that's what we want it to be. We're looking for the slope, so we're looking for the m. If we look at this line, the m is going to be 2. So I know line 1 slope is equal to 2. Now we need to find a line that is parallel. So if we are parallel, the line 2, or the parallel line, we know the slope needs to be the same thing because parallel lines have the same slope. So the slope is 2, okay? Well, we know it contains this point here, 0, 4. So that's x and a y, okay? Well, we have to look back and think back to our notes from yesterday. If you were here, if you weren't here, we learned a new equation yesterday, and it's for point slope form. And I want you to write this down. Let's see where we have room. Down here at the bottom, okay? So point slope form. This is how you can write an equation of a line if you just have the coordinates and a slope, okay? So you have a point and you have a slope. So up here, we know my slope is 2, and we know I have a coordinate of this guy here, 0, 4. So our formula says, and write this down please, y minus the first y coordinate equals the slope times x minus the first x coordinate, okay? So if we wanted to do that in this example, we know the slope is 2, and we know our x and y coordinates. So we could fill in this equation, y minus 4 equals the slope, which is 2, times x minus this guy over here, 0. Okay? So if we wanted to get that in y equals mx plus b, we would just have y equals 2x plus 4. That's the equation of that line, okay? So that's how you're going to have to do that. Find an equation of these lines. That's what you'll need to do. Okay, so the equation of this line is y equals 2x plus 4. There's that one. Okay, so let's talk about this one. We need to find a line parallel to this. And we have a b, or a y-intercept. So the b is the y-intercept, and it is 7, okay? So if we have a y-intercept, that is the point on my graph where I intersect this. My x-coordinate would be a 0, because we didn't go over this way, we didn't go over this way. So my x-coordinate is 0, my y-coordinate is 7, okay? So we actually are given a coordinate here. Okay, so be mindful when you're given your b value, you do have a coordinate. It doesn't look like it, but you do. The first thing you need to do, get these, and y equals mx plus b. Okay, that's what we need to do. So we need to rewrite our equation, 2x plus 3y minus 6. And matter of fact, because that's not going to work if we do it this way, we need to change this plus to an equal sign. So please do that. Sorry about that. Okay, so we need to solve for y to get it y equals something. So we want to get this by itself on one side. So I'm going to go ahead and add 6 to both sides. If I do that, we get 3y equals 2x plus 6. My next step would be to keep solving for y. To do that, I'm going to have to divide everything by 3, because what you do to one side, you have to do to the entire other. So then we would get y equals 2, because 6 divided by 3 is 2, plus 2/3 x, okay? So this is y equals mx plus b. We can just rewrite it as y equals 2/3 x plus 2. All right? So what's my slope? The slope is 2/3. So line 1, we know our slope is 2/3. And we are finding a line parallel to this. Parallel line means same slope. Okay, so in our parallel line, I know I need to have y equals, and I have the same slope, so 2/3 x, and then guess what? We're in y equals mx plus b. You're given a b. So all you have to do is plug it in. So I know b equals 7, so down here, just replace your b with a 7. And that is the equation of your line, because we are given that. So you can either do it the point way, or you know you're given your b, so you can do it that way. Okay, so that's how you would do that problem. You can pause and rewind at any point if you need to see how to do it. We need to find a line parallel to this, so parallel lines have the same slope. Looks like this is already in y equals mx plus b, so all we have to do is look at our, so y equals mx plus b, we just have to look at the m. So we can see that the m is -1/2, so same slope, we need to have a slope of -1/2, okay? And it needs to contain this point. So if we have that, we have to go back down to the bottom. We got to use our point slope form right here, okay? So y minus y1 equals m times x minus x1, okay? We know a x and a y coordinate. We know x1 and we know y1. So all you have to do is plug these in, because you also know your slope here, okay? So all we're doing is replacing these and plugging these in. So the 1's going to go there and the 4 is going to go there. So what we're going to rewrite is y minus, and then we're going to plug in the first y coordinate, sorry. And then this is going to be equal to the slope, which is -1/2 times x minus, we're plugging in the x1, which is 1. Okay. And then from here, we just need to simplify it. So it's in y equals mx plus b. So you just have to distribute your 1/2. So then you have -1/2 x minus the -1/2 times -1 is going to be a +1/2. And then we just have to add the 4 over to this side to get y equals. So if we do that, we're going to get 4.5. So our actual equation here would be y equals -1/2 x plus 4.5, because we have the 4 plus 1/2. So that's how you can do that. You could also write that as a fraction. Okay, so over here, perpendicular lines are going to have the opposite reciprocal slope. So opposite reciprocal. So looks like we are already given equation in y equals mx plus b. We're going to find the m, which is the slope. So we know our m is equal to 5. We need to find the opposite reciprocal. So the opposite reciprocal of 5 is just going to be 1/5. So -1/5. Okay, so we need to find the equation of a line perpendicular to this line. So we know y equals, we have -1/5, because that's our slope, x, plus we need to figure out our b value. So it looks like the b value is given to us, so we can just plug it in. These problems are much easier, because all you have to do is plug in your b value. So that's the equation of that line. All right. So perpendicular to this one, containing that points. So we have to do perpendicular. So my slope in this line is -2/3. Okay, so the slope for a perpendicular line is going to need to be 3/2, because that's the opposite reciprocal. Okay, so we have y minus y1 equals, using that point slope form. Okay, so now we're just going to plug in what we have. So y minus, where am I getting the y1 from? Over here, 3, equals m. Where am I going to get the m from? Right here. So all we're doing is kind of plugging into these formulas, and then minus the first x, which would be 0. Okay, now we're just going to simplify this guy. So all we have to do is distribute this. That's going to be 0, so that's easy. So we have y minus 3 equals 3 halves x minus 0. So that's gone. Then just add 3 to both sides. And then we get y equals 3 halves x plus 3. That's the equation of our line. Easy peasy. Moving on. This one here, perpendicular to x equals 5. Well, x equals 5 is a horizontal line. So if we have a horizontal, sorry, not a horizontal, it's a vertical line. If we have a vertical line, we know that a parallel line, or not a parallel, a perpendicular line is going to be horizontal, okay? So these two lines are perpendicular. So how do we find this? What do we do? Well, I know it has to contain the point 32. So I need to look at my x and my y. Now, a horizontal line is going to be y equals something, okay? What's my y coordinate here? It's 2, okay? I know on a, if we draw a graph here, if I have a horizontal line, I know y is always going to be 2, no matter what x point I have. So literally we can come up with the equation of the line. It's y equals 2, okay? So that's the equation of that line. So I know that looks crazy. Please pause the video, rewind, watch anything that you need to do. You have an assignment on Canvas. Please make sure you show all your work. You have 4 problems. Make sure you show that and get any missing work done that you need to do, okay? So if you need to pause this at any point to see the notes, you can do that, and they're also going to be uploaded on the Canvas as well.